Okay, so we are starting 2.5, starting with 2.5, order of operations and algebraic expressions. So this class starts off with 2.5 and then goes to 4.1. And those sections will be reflected, in your homework. So when you go to homework 1, you'll see 2.5, 4.1, I think it goes to 4.4 and something like that. But you'll see it all labeled in Connect Math. All right, so order of operations and algebraic expressions. So here are our order of operations. We have PEMDAS. Some of you may remember that from, back in elementary or whenever you first introduced PEMDAS. P is for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. All right, so when it comes to this, we're going to have 4 tiers of operations. See, our first one is parentheses, but also any grouping symbols will get our attention first. So you see parentheses, brackets, and braces. Then we have our exponents. Multiplication and division, we'll do them from left to right. So multiplication doesn't take any precedent over division. We do it from left to right, and the same thing with addition and subtraction. So we have 4 levels of operations. All right, I'll give you a chance to write that down before I scroll up. All right. And if I ever scroll up, remember I can't see, most of you. So if I ever scroll up and you're still writing, just unmute yourself and say, could you scroll back down for a second and then let me know when you're finished and all that stuff like that. So just throwing that out there. So here's a quick example of what I mean by doing your operations from left to right and how multiplication doesn't take precedent over division. Let's say if we have 18 divided by 9 times 2. So when we look at this first one right here, 18 divided by 9 times 2, if you say do it as far as the order that you see PEMDAS in, multiplication first, then division. If you do 9 times 2 first, that would be 18, then 18 divided by 1. 18 divided by 18 is 1. But this is the incorrect way of doing it. Once again, multiplication does not take precedent over division. You do them both from left to right. So what we should do first is 18 divided by 9, which is 2. And then 2 times 2 is 4. And so I like to do this because it gives us, make sure we dispel the idea that just because I come down with a solid answer, like the number 1, it doesn't mean I have the right answer. So, there's always a right way and a wrong way to do this stuff. So make sure when it comes to multiplication and division, you do it from left to right. Same thing with addition in comparison to subtraction. All right, so the next one, first real example, negative 12 minus 6 times 7 minus 5, the quantity of 7 minus 5. So the first thing we'll do is what's in the parentheses. Remember, parentheses or any grouping symbol gets our attention first. Do the 7 minus 5. That'll be negative 12 minus 6 times 2. Next thing we want to do is the 6 times 2. And that's 12. So we have negative 12 minus 12, which would be negative 24. All right. Questions. And here with your signs, don't forget this was negative 12 plus negative 12. That's the same thing. So that's why we ended up getting negative 24. All right, the next one, 6 plus 48 divided by 4 times negative 2. So notice we have three operations here. We have plus, division, and then multiplication. And the first one that should get our attention first is our division. So we'll do 48 divided by 4, which will give us 12. So that's 6 plus 12 times negative 2. Then we'll do multiplication. 12 times negative 2, negative 24. And now add them together, we have 6 plus negative 24, which is negative 18. All right. Yes, you got your hand raised. Is that Miss Moultrie? Am I saying that right?
Yeah. Quick question. Why did you do the division first and not the parentheses?
Well, there was nothing inside of the parentheses. So that's a great question. If there was something in here with it, then we would have done that first. So in other words, let's say if it said negative 2 plus 5, then we would have done what was in here first. But since there was nothing in there, there was nothing for us to do. And so pretty much this parentheses is just here to separate, these two symbols. And
Got you.
that,
Got you.
thank you, thank you. Good question. All right. Anybody else before we scroll up to another one? All right. So let me erase some of this stuff. All right. So here we have 3 squared minus 10 squared divided by the quantity of negative 1 minus 4. And so this is one of the ones that would fit Ms. Moultrie's question. We're talking about something inside of the parentheses. So we would do that first. And negative 1 minus 4 would be negative 5. Then the next thing that should get our attention would be the exponents. And so 9 squared is, 3 squared is 9, 10 squared is 100. All right, then we'll do division. 100 divided by 5, negative 100 divided by negative 5. It will give us a positive 20. Negative divided by negative is 20. And then 9 plus 20 is 29. All right. Scrolling up, scrolling up. All right, somebody said something in the chat. Let me see. Oh, that was it. Oh, you're just saying you're good. Okay. I was about to say. All right, cool. All right, so the next one we have, let me erase this stuff. We have the absolute value of negative 8 plus 24 over 5 minus 3 squared. And over here, I was just emphasizing the effects of the absolute value. It always gives you the positive result. So whenever you take the absolute value of a number, the absolute value of negative 3 is positive 3. Absolute value of positive 1/4 is still going to be positive 1/4. Absolute value of negative 0.7 will still be positive 1/7. So when you take the absolute value of something, you always get the positive result. It's not the opposite. You always get the positive result. So what I'm going to do here is simplify as much as I can with the numerator individually. then simplify as much as I can with the denominator individually. Then we'll bring them together and simplify. So when I look at that numerator, absolute value of negative 8 plus 24, negative 8 plus 24 is 16. It's right here, and then the absolute value of 16 is 16. Then looking at your denominator, we have 5 minus 3 squared. So first thing we'll do is a 3 squared, which is 9. Then 5 minus 9 will give us negative 4. All right, so now we can put them together. 16 over negative 4, or 16 divided by negative 4, will just be negative 4. All right, questions? All right, so next one. 5 minus 2 times the quantity of 8 plus the quantity of negative 5 minus, negative 7 minus 5. There you go. So whenever you have grouping symbols embedded in another set of grouping symbols, you want to do your innermost grouping symbol first. So you have negative 7 minus 5 is the first thing that we'll do. And that gives us negative 12. From there, we still have an operation inside of a grouping symbol, so we'll take care of that. So 8 minus 12 will give us negative 4. Then here, whenever you have a number right up against a grouping symbol, that's multiplication. So that's what's going on right here. 2 times negative 4. Well, got about this, I didn't even look at it. So that's negative 2 times negative 4, which would be positive 8. Negative 2 times negative 4 give you positive 8. And then 5 plus 8 is 13. All right. Let's see how many more we got. Oh, got like one more type of thing. So questions before we go to the next thing. All right. So next thing, and I think this is the last type of thing in this section. Oh, still a few more things, but it's not that much left. Okay. So we want to write each phrase as an algebraic expression. So that first one, the product of negative 6 and x. So in the red, you see that we have keywords or key phrases that's going to let us know what operation to use. In this case, it's product. Product means multiplication. So basically, all you're doing is multiplying negative 6 and x, and that'll be good enough. A couple different ways you can represent the multiplication. You saw the dot. You could do that as well, but the simplest way is negative 6x. All right. The next one, be careful. we have p subtracted from 7. So 7 minus p would be the result here because you're taking p from 7. So a lot of times people can, want to do p minus 7 because that's the order that you're given. But when it says p subtracted from 7, you want to take p from 7. You have to do 7 minus p. All right. Next one, the quotient of C and D. In this case, the key word is quotient, which means division. And so that's just C over D, or you could do C divided by D with that divisional symbol. Either one is fine. Unless they say specifically write as a fraction. They say something like that, but all right. Questions? Any questions? All right. And then here we have two keywords, and this that'll let us know what we should be doing here. We have twice the sum of y and 4. And so sum means add, and twice means multiply by 2. So we would do this like that. 2 times y plus 4 and use parentheses around y plus 4. So using parentheses, remember, means that we're going to do that first. So I'll add y and 4 first, which would be the sum of y and 4, and then I'm going to twice it. Or in other words, multiply it by 2. All right. And then here, I was just emphasizing the difference between twice in the term and twice in the sum of. So if it just said twice y, then that's 2y. But here it says twice the sum. So that's why you needed those parentheses. That's why you needed parentheses. All right, any questions with that exercise before we go to the next one? And those keywords, they should be in the book. Let me see if what page it's on, just in case somebody wanted to reference that. Oh, this book didn't give you a page. That's why I didn't write it down. Okay. I will, I'll see if I can find that and scan it. I know I have it in another book. This book didn't put a little box with key phrases up there and tell you what they mean. So let me write that down. I'll try to scan something and send it to you guys. All right. So next one, evaluate. So in this case, they'll give you an algebraic phrase and then they'll give you numbers to plug in for the unknown for those variables. So we have 3x minus y, and they want you to evaluate for when x is equal to 7 and y is equal to negative 3. So all that means is you plug in 7 for x, negative 3 for y, and then do the calculations. So that's what I did here. That was 3x, so that's 3 times 7, minus y, so it'd be minus negative 3. All right. So 3 times 7 gives us 21. Negative to negative turns positive. And then adding those together will give us 24. All right. Next one, 4a plus b. So a is equal to 8, b is equal to negative 52. Plug them in accordingly. That's 4 times 8. And then it's plus negative 52. 4 times 8 is 32. 32 plus negative 52 would be negative 20. All right. Any questions? Shoot, all right. Okay. So here I was just emphasizing some things about absolute value. Let me erase some of this and walk through it. So just difference between seeing a negative involved with the absolute value symbols and what our absolute value symbols are and how they apply. So mentioned before, especially when we look at this last one right here, the absolute value of negative 6 is going to be 6. When you apply the absolute value to any number, it's going to be the positive result. In this one right here, the absolute value of negative 6 is still going to be 6, but there was a minus sign or a negative sign that was sitting on the outside. So that negative sign will still be sitting on the outside even after you apply the absolute value. I guess I could have made it red. So that negative is still sitting on the outside of the symbolism or outside of parentheses. And so your final result will be negative 6 because that's the same negative that's sitting on the outside from the very beginning. That's not affected by the absolute value. Now in this second one, those are not absolute value symbols. So negative to a negative, as we mentioned earlier, will be positive. So that'll be a positive 6. Negative to a negative cannot apply here because the absolute value is an actual application. So that's why that couldn't apply here. The parentheses aren't applications, they're just grouping symbols. So once again, negative to negative in this case turns our 6 positive. Negative negative right here does not occur because there has to be the application of your absolute value first. So any questions on that? Make sure we're good. All right. And similarly, we have a little bit of that same type of situation when it comes to the power, when you're applying the square or any power. If you want to include the negative as a part of that application of the exponent, you have to use parentheses. So in other words, when we look at this one right here, didn't mean to do that. When we look at this bottom one right here, that's negative 3 squared. So that'd be negative 3 times negative 3, which is a positive 9. But in the top one right here, that's negative 3 squared, but the negative is not affected by this square because there are no parentheses around the negative. So that negative is going to sit on the outside, never affected by the square. And the only thing that's being squared is the 3. So that's negative 3 times 3, which will give you a negative 9. So that's the difference between these two. If you want your negative to be included or be affected by the exponent, you have to use parentheses around the negative. So that's something that people can even mess up or think they're putting the right thing in the calculator. Once again, one will produce a negative 9, the other one will produce a positive 9. Questions? Any questions? All right. Let's see what 4.1 is. That's not that bad. We can go ahead and do this. Got a few minutes left. So next section is 4.1, Introduction to Fractions and Mixed Numbers. So in the example of 3/4, our top number is our numerator, denominator is our bottom number. That will always be the case when you look at your fractions. Your top number will be your numerator, bottom number will be your denominator. There are three types of fractions. Proper fraction is when your numerator is less than your denominator. So 2/5 is an example of that. Improper fraction is when your numerator is greater than the denominator. 10/7. And then mixed number is going to be the sum or combination of the whole number and a proper fraction. And notice it said proper fraction. So in other words, you're talking about numerator being less than the denominator as far as that fraction is concerned. You have that whole number of 3, then a proper fraction, that's 1/9. All right, gonna scroll up. All right, so we're going to write a fraction for the shaded portion. So when we look at this exercise, the shaded will be the top part, and then the bottom part, or the bottom number, will be how many pieces it takes to make a whole, the whole shape. All right, so you're talking about the whole shape. You're talking about this whole thing right here. So we see that there are 3 shaded pieces, but then there are 5 pieces that make the whole shape. Once again, if I scroll up and you're still copying, let me know. All right, next one. As far as shaded pieces, we have 7 shaded pieces. If you count 1, 2, 3, 4, 5, 6, 7, then you ask yourself how many pieces does it take to make a whole? Talking about a whole circle, that'll be 3 pieces. So 7/3 is one way of representing it. Then the other way is doing it as a mixed number. You're talking about 1, 2 whole circles that are shaded, which is that 2, and then we have 1 out of 3 that's shaded. So that'd be 2 1/3. All right. So 2 wholes and 1/3 of a whole. Any questions? All right. So next we're looking at converting mixed number to an improper fraction. So we're going to multiply the whole number to the denominator, add the result to the numerator, and keep the same denominator. All right, so we already wrote it. First one, 7 and 1/4. So you take your whole number with the 7, multiply it to your numerator, add that to the denominator, multiply to the denominator, excuse me, and add that to the numerator. So 7 times 4, and then plus 1. So 7 times 4 is 28, plus 1 is 29 over 4. So once again, whole number times the denominator, add it to the numerator. All right. Same thing here. We have -8 and 2/5. So if you're going to do or convert an improper fraction that has a negative, that negative just sits out front. You don't do anything with that. But then you will do the process of 8 times 5 plus 2. And so that would be 42 in your numerator. And 5 that stays in your denominator. All right, any questions? All right, so we're now going to take it the other way. We're going to convert an improper fraction to a mixed number. So first we'll divide by using long division. And then we'll write the mixed number in this fashion. Quotient will be our whole number. And then we'll take the remainder and place it over the divisor. So when you talk about what is the quotient is your answer part. And you'll see in a second when we go through the process. Your remainder is what's left. We're not converting to decimals, so your remainder will be what's left at the end of your division process, and then your divisor is the denominator that you had initially. We keep that same denominator. All right. So if I have 25 over 6 and I want to write that as a mixed number, I would divide by using long division, 6 into 25. 6 goes into 25 4 times. 6 times 4 is 24, and that gives us a remainder of 1. So this 4 right here is your whole number. That's the quotient. And that's what goes right here. And then that 1 is your remainder. And you see that's what goes up here top. And once again, you keep the same denominator. And you always can check it by using the process we talked about before. 4 times 6 is 24, plus 1 is 25. That gives us our 25 right here back. Questions? Any questions? Hold on 1 second. I got any more? Yeah. All right. Next one. Same process. 39 over 4. Take 4 and divide it long division into 39. 4 goes into 39 9 times. 9 times 4 is 36. 39 minus 36 is 3. So our mixed number would be 9 3/4. Any questions? Any questions? Let's see if this. Okay. Well, these we talked about this process already. Like before I go there, I was seeing if we had anything left. Everybody good with this? Everybody good? Okay. So the absolute value holds true to fractions as well. Somebody said something in the chat. All right, cool. Thank you. Thank you. So absolute value of negative 2 over 7 is still 2 over 7. Absolute value of 1/5 is 1/5. Here we remember we talked about the negative sitting on the outside of the absolute value, not affected by the absolute value. So negative absolute value of negative 4 over 9 will be negative 4 over 9. Notice it turned from here to here, went positive because of the absolute value symbol, but still had a negative sitting on the outside. And here, once again, just emphasizing, the difference between seeing absolute value and parentheses. If you see parentheses, then negative to a negative turns positive, and you're left with a positive 4/9. But once again, that could not happen here because those are absolute value symbols. And the last thing is just properties of your fractions. Just general properties. The first one, a over 1. A just represents any number. So any number over 1 is itself. Over here, we're just doing examples. 5 over 1 is 5. 100 over 1 is 100. So that's all we're doing over here, just emphasizing that. I got lazy with some of this writing. But it's all good. So here, 0 over a is going to be 0. Once again, over here, we're just emphasizing that with examples. If I have 0 over 5, that'd be 0. 0 over 100 is 0 as well. So 0 over anything will be 0. Anything over 0 is undefined. So don't forget that, because it will come up again, and they're going to hold you to it. So, all right, so somebody say something in the chat. Oh, it's up to you, as far as, if you want to copy it down or not. But it's something, like I said, just like with the undefined thing, 0 in your denominator, they're going to hold you to remembering that. Something over 1, y'all might, that might be easy, nothing to write down. But a lot of times people mistake, let me go back here. A lot of times people mistake these two, and they will give 0 for this one. And that's going to be undefined. So you most definitely need to remember that anytime you have 0 in your denominator, that's going to be undefined. And once again, those are examples of that. 5 over 0 is undefined. 100 over 0 is undefined. All right. Anything over itself is equal to 1. So 5 over 5 is 1. 100 over 1 is 1. And here, I think somebody asked a question, but I can just go over it anyway. Just emphasizing here, negative over negative. Negative over negative would be a positive fraction. Here, I was emphasizing that having a negative out front, the negative up top, or the negative down bottom, they all mean the same thing. It's just notation. And when it comes to math, you will not see this one as your final answer. So you normally don't leave the negative down bottom in your denominator. So you either bring it up top, like this one, or you put it out front, bring it out front. But you do not, leave it down here. That's just notation. But they all equal the same thing. And I was just using numbers down here to emphasize the AB relationship. So negative 3 over negative 4 is going to be positive 3/4. And then, like I said, all three of these mean the same thing, whether it's sitting out front, up top with the 3, or down bottom with the 4. And that's it for those two sections. That's it for those two sections. Any questions? Any questions, concerns, comments, anything, anybody? Before we close out today. All right, thank you.
Oh yeah, I have a question.
Yes.
I was just wondering if we were gonna go over like combine like terms. Like
Yeah,
later, I
we're gonna get there.
Okay, thank you.
Yeah, not a problem. Forgot which section that is, but yeah, we most definitely gonna get there. Yes, Mr. Henderson.
Yes, I wanted to know, like, do we have any worksheets or anything that we need to fill out after reviewing this stuff that we reviewed today?
When you go into not web assignment, to Blackboard, you have Connect Math assignments to do. Were you here the first day?
No, I wasn't, because I just changed my major.
Yeah, no worries. It's all good. I was just making sure I wasn't giving you information you already had. That's all. So let me see. Let me pull this side. And this can be for anybody, so we can just talk about it real quick. We got a few seconds.
hmm
All right. Trying to share my screen. All right. So right here we have Connect Math. So it's right under course information. Click on McGraw-Hill campus. Click on Connect Math right here. And here go all your assignments. Yep. And I see the first assignment. So the first thing that they set up for you guys is to take the pretest. So please do that. Just I'll just go ahead and give you easy credit for that, no matter what you got on it. You do want to do your best, but it will not be a pass or fail type situation. More so a participation grade. So I'll use that as credit. Pretty much an easy grade. And then we're looking at our first homework right here, homework one. Notice it starts at 2.5 and then it goes into 4.1 through 4.4. So that's your first homework assignment. And so nothing is due today. When I say today, nothing is due by next class. But what you want to do is do your assignments and try to keep up with the lecture and be as close to the lecture as possible. But if you're not there, no harm, no foul. But when we get closer to closing out the first test, Then we'll talk about due date or something that along those lines. And let's just get further set up or further into the course before we actually look at due dates. But right now everything's open. I know he got February 7th up there, but February 14th for the first one, but that can be flexed. Especially it depends on how we're doing the lectures and how everybody's doing it in their homeworks and everything like that. But there will be a due date, but right now I don't know exactly what a due date is going to be. It would depend on the lecture and how we're flowing. So, yep. And whenever there's a due date, I'm going to establish it. This course was set up by a course coordinator, so all of those due dates were put in there by him. But I'm gonna, like I said, I will flex them according to how we flow with the class. All right. But once again, you guys want to do your best to, you know, keep up with the lectures, let your homework match where we are in the lectures. We just did 2.5 and 4.1. So you want to at least be looking at those two sections, before coming into next class. Even if you haven't completed them, you want at least, taking a look at them, see if you have any questions on them, see if you need to ask questions. Don't forget to look at that thing I sent to you about Connect Math if you have any concerns or questions about grading. And we'll go from there. Any other questions? Hopefully that answer your question, sir. Mr. Anderson.
Yes, it did. Thank you.
All right, not a problem, not a problem. And let me say this before I go to Ms. Vaughn. Don't forget, you guys do not have to pay for anything. So you should be able to log in, and I think they want you to register when you go in there, but you shouldn't have to pay for anything. So just throwing that out there. Ms. Vaughn.
Yes. Being that we went over 2.5 and 4.1, are we able to do those and then go back into that homework to do 4.4?
Yes. Yeah, you can go in and out, save, and come back later and all that stuff like that. Yep.
Okay.
Yep. Good question. Good question. All right. Anything else? Anybody else before we close? Is everybody good? All right, Ms. Vaughn again.
No, I'm sorry, nothing.
Okay, not a problem. Mr. Henderson again.
Yeah, I was wondering about the book because I thought we had to like buy it from the library or something like that. Am I able to just click on it and then review like the problems that's in the book, right?
Yeah, there should be the e-text that come along with it. And I have a hard copy of it, but that hard copy is the same copy that you have that's built inside the Connect Math program. And you can go review the book through that. All right, did somebody else say something? I heard something.
I don't know how to do.
Oh, okay. Let's go back
Yes.
to it. Let's see. Resources is probably under resources. Practice, reference, course files. Let's do this. Oh, hey, go right here. I knew it was an easier way to do it. Right here on the right. See how it says ebook.
Okay. Okay, got it.
Yep. Another way of doing it though is when you're doing one of your assignments. Let me share this screen because I had a pop up. All right, so wait for this to pop up. Okay, right here, link to textbook. That's another way of doing it. If you're actually in, your assignment doing a problem, you can click this link right here, and that'll take you to the textbook where this type of problem is discussed. So that's another way of getting to the ebook. All right. Anybody else? Anything else before we close? So everybody good. And just like before, if you think of something after we close out, feel free to shoot me an email. Or if you just want to wait till next class, feel free to do that as well. But the door is open to ask whatever questions you like on whatever day. Anything else before we go into the weekend? Everybody good?
Yeah, thank you.
Yeah.
All right, cool. Thank you. So appreciate you guys coming through. I will see you on Monday. Have a great weekend and be safe.
Thank you.
All right, thanks. Thank you. Take care.